Hello everybody, and welcome back to another day of 7th grade math here. So just like yesterday, we're going to be moving forward in applications of these proportions. So we've seen a bunch of applications with unit conversions, percent problems, they even help us out with taxes and tips and discounts sometimes. So what we are doing today is we're going to be using our ratio tables here to set up proportions. So let's just dive right into it. So the following chart shows the time that the snail travels in a certain period of time. If the snail moved at a constant speed, find out how far it can travel in 130 seconds. So our steps are telling us to set up a proportion here. Use the ratio from the word problem, so it gives us the ratio here in our example. 130 seconds over x inches, and any one ratio from the chart. So, how do we know that we can use any ratio we want to? Well, the whole idea behind this proportion stuff is that all of these ratios are equal. That's what makes these proportions special. So let's give it a try. If I do 10 for this first one here, if I do 10 seconds divided by 1.5 inches, I get 6 point, I'm gonna round it to the 100th, 67. So now we'll try out 20 divided by 3. Whoops. 20 divided by 3, I get 6.67. 25 divided by 3.75 is going to give us 6.67. I think we get the idea. So the ratios are all constant here, and that's why these proportional relationships allow us to set things up like this and allow us to pick anything we want to out of there in order to use. So what they're doing is they're taking their 130 seconds over x ratio that they got here, because we don't know how far that snail went. That's what we want to know. And they're setting that equal to, well, they just went ahead and chose the first ratio there, which is allowed. You can do that. So 10 seconds over 1.5 inches. So remember, units, if you're doing seconds on top, then for both of our ratios here, seconds has to be on top. And then inches on the bottom, inches on the bottom. Units gotta be on the same level when you're setting up your ratios. And then they are cross multiplying here, so 10 times x, that's where they get that one there. And then 130 times 1.5 gives them 195. So we've been doing this long enough, a couple weeks now. This should be the easy part, doing this butterfly method and getting to our answer. So the setup can be a little difficult sometimes, but once we get it correctly set up, this all just becomes simple, simple, simple. So 10x equals 195. Well, we just got to divide by that 10 in order to solve it, and they get 19.5. So remember, always include the units with your answer. So 19.5 inches is what they get for their answer here. And then let's test it out. So if I do that, so we were worried about 130 seconds divided by those 19.5 inches, what do you think that ratio is going to turn out to be? Well, if we did it correctly, it should end up being the same as all of these ratios that we got up here, because this is still proportional the way we set it up. Let's test it out. 130 divided by 19.5. Well, sure enough, we get 6.67, the same ratio as all of our other examples from the table. So that's a good way you can check to see if your answer is correct, as long as you divide it the same way. So we did time divided by distance here. So to test it out, your answer, divide the time you were worried about 130 seconds by the distance you got and see if you get the same ratio. If you get something different, you'll know that you might have to go back and check one of your steps there. All right, so just like before, what I want you to do is pause the video here and try to set this up and solve it yourself. So just hit pause, give it a try, and I'm going to walk through it right now so that you can take a look at how you did. You can compare it and see what you might need to fix here. All right, so the chart shows how many hot dogs Dabney can eat in a certain time period. Use the information from this chart to find out how many hot dogs he can eat in 17 minutes. So let's just double check that this is proportional real quick. Let's divide our time by the number of hot dogs. So 2 divided by 7 is, I'm going to round it to the 100th, 0.29. 5 divided by 17.5, 0.29. And I'm not just rounding it to make it the same. The extended decimal is the same as well. I'm rounding all of these same numbers to the same thing. 9 divided by 31.5 is going to be 0.29. So I think we're getting the idea that this is proportional, and we're absolutely sure now. So they did minutes divided by hot dogs, so we're going to set this up. We've got 17 minutes to eat. We don't know how many hot dogs. That's what we're worried about finding. Equals. And now we can choose whatever we want to. So it's usually easier to keep our numbers that we're working with as small as possible if we're allowed to choose what we're working with. So I'm going to pick this first ratio just like they did up above. So this was 17 minutes and how many hot dogs. So remember, we got to keep our units the same up top. So we're going to go 2 minutes here and 7 hot dogs. So from here, like I said, this setup can be the most difficult part sometimes. So what we want to do is just that butterfly method. 2 times x is going to give us 2x equals 17 times 7, 119. Just a one-step equation from here. So to undo this multiply, I divide by 2, and x is going to equal 119 divided by 2 is 59.5. So it looks like in 17 minutes, this person could eat 59.5 hot dogs. Don't forget your label. All right, and just to be absolutely sure, we're going to divide our 17 minutes divided by 59.5 hot dogs. 17 divided by 59.5. Double checking. We get the same decimal as before, that we are rounding to the same place. So we know this checks out, and we know we did a good job with it. All right, so one more example here, really quick set of notes today. Just a couple examples to work us through. So remember, pause, try your setup, try to solve it, and then push play again so that you can take a look at how you did. All right, so Sean is practicing for the 2020 Olympics. His marathon swimming coach wants to know how far Sean can swim in 30 minutes if he swims at a constant rate. So once again, if it tells you it's proportional, you can trust that it's proportional. This doesn't, and we don't just want to assume that it is. So what I'm going to do, just real quick, double check these. I'm going to divide 2 by 26.5. We get 0.0754, etc. So I'm just going to round this to 0.08. 11 divided by 145.75 is going to give us 0.0754, etc. So same decimal, 0.08. Once we get past a few, we can start to trust it, but you never know, so just double check. 12 divided by 159.08 that I get from rounding the exact same decimal as before. And we're at the end, so why give up? Let's just check this last one. 24 divided by 318, the exact same decimal that I'm going to round the exact same way. So we know it's proportional. We have equivalent ratios all the way through. So they're doing minutes divided by distance, so we're going to set this up the same. So we've got time is 30 minutes divided by X meters, because that's what we want to know. Also, if you're choosing from a table which ratio to use, a lot of times easier to keep it with whole numbers here. So instead of testing this guy or this guy, what I'm going to do is use the first whole numbers that I'm given. So I'm going to do 12 minutes over 159 meters. And then once again from here, this is all just butterfly method stuff. So 12x is equal to 30 over 159. Oh, whoops, excuse me. I'm supposed to multiply those, I'm sorry. So 30 times 159 is going to give us 4,770. Divide by 12, divide by 12, and x should equal 397.5. So let's see what happens if I decided to choose a different setup. So 30 over x equals, so now I'm going to use 24 over 318. So we get 24x equals 30 times 318, 9,540, divided by 24. What do we think we're going to get here? Well, because of these equivalent ratios, remember, we should get the exact same thing. So let's test it out. Divided by 24, and sure enough, we get 397.5. So that's just showing us that we can literally choose any ratio we want from up here in order to help us solve this. But never hurts to double check, so what we're going to do is divide those 30 minutes by 397.5. Oops, I forgot to label this too, meters. 30 divided by 397.5. And once again, I get the exact same decimal as I did before, that I am rounding the exact same way. And we know that these ratios are equivalent, so we know that this is the correct distance he can swim in that amount of time. All right, so looks like that's all the examples for today. So use this to help you through your assignment there. So our assignment starts on the next page within Canvas. There's a PDF like always. So go ahead and open that up, and then you can use your notes here to help you through figuring out those problems. All right. As always, if you have any troubles or issues, please email me, and I will get back to you as soon as I can. Alrighty, thank you, and have a great day.